name is Vincent. In iOS XR 7.3.1, we are introducing 400GB DCO in QSFP-DD pluggable form factor. 400GB DCO is a key component of the Cisco routed optical networking architecture. The Cisco routed optical networking architecture is about simplification and automation. It converges multiple planes of optical, TDM, and packet layer into a single hop-by-hop IP layer with segment routing control plane. On the optical side, it uses simple point-to-point DWDM, and the transponders are integrated into the routers with 400GB DCO pluggable optics. The key objectives of the DCO design is to be open and standards-based, so with multi-vendor interoperability. DCO stands for Digital Coherent Optics. Basically, it integrates a transponder into the router for simplification and cost optimization. In the first generation of 100GB DCO, it was the size of a whole line card and with very high power consumption. With the advances in technologies such as silicon photonics and high-performance DSP with 7nm processors, we are able to integrate a 400GB DCO into a QSFP-DD pluggable form factor with very low power. The use of QSFP-DD ensures that we are not sacrificing router port density with integrated DCO. In terms of standards, OIF is the first to come up with 400ZR coherent standard for simple point-to-point 400GB Ethernet data center interconnect. On the other hand, the Open ROADM MSA has also defined a full-fledged standard with multiple rates, flexible Ethernet and OTN client mapping, and a high-performance spec enabling regional and long-haul applications. The OpenZR Plus MSA attempts to combine the best of both standards, retaining the simplicity while keeping the multiple rates with high-performance spec. This simplification allows 400GB ZR Plus to be integrated into a QSFP-DD pluggable. Cisco and many other vendors are active members of the OpenZR Plus MSA to ensure multi-vendor interoperability. This is a quick summary of the differences between standards. The audience could go through it in more details later, together with the reference readings at the end of this presentation. Please note that the OIF 400ZR standard only supports 400GB transponder mode. However, Cisco does offer an extension for 4x100GB muxponder mode. Cisco NCS 5700 series for both modular line cards and fixed platforms will support both ZR and ZR Plus pluggables. In the current 7.3.1 release, the 400GB ZR will be supported first with the release of its mode. In the next XR 7.3.2 release, we plan to support the 400GB ZR Plus as well. These are some of the references on Cisco.com and the recent Cisco Live 2021. Enjoy your reading.
Hello everybody, this is Bernhard and I want to talk to you today about the optics support that we are adding under the iOS XR 7.3.1 release. We've added miscellaneous support for various optics. I want to highlight today 3 different sets of optics that we've added under 7.3.1, and that is the 400GB ZR type optics, the QSFP 100GB FR optics, and the SFP 10GB-ZR-I. What is 400GB ZR? ZR optics are the first time we bring coherent technology to the 400GB lineup of modules. Coherent is the enabler for long-distance transport. In this case, we have 2 different versions, one being the so-called 400GB ZR, which covers distances up to 120 kilometers, and one being a 400GB ZRP, or often called ZR Plus, which can cover distances up to several hundred kilometers depending on type of modulation. Under 7.3.1, we are only going to support the ZR type optics. The ZR Plus or ZRP is going to come with 7.3.2. It is important to note that at FCS of 7.3.1, we will only have limited support for the 7.3.1 optics, and we will later, in end of April, early May, release then the smooth for final general availability, GA support. The reason for this being that the modules itself will only go FCS end of May, and we need to be able to potentially react to some last-minute changes in the optics module firmware. And that's why we are looking at a smooth that is to come then in April timeframe. Although these modules are called ZR, which refers to, in common language, distances up to 80 kilometers. These modules can go beyond 80 kilometers, which is nice to see. But natively, when you use ZR or ZR Plus optics and you want to connect two systems back to back, the maximum you can reach in the basic setup when you just use fiber in between these two nodes is up to 40 kilometers. There is not enough optical budget available to cover natively 80 kilometers of fiber. So you always need to pay attention when you want to use ZR optics. The very moment you get to 40 kilometers or a little bit more, you will need to add an external optical amplifier to the setup. Next thing I want to address is the 100G FR-S module. The 100G FR-S module is important when you want to use the new 400G optics in 4x100G breakout. And here especially there is the QDD 400G-DR4 module that is organized in 4x100G. You can use them when you connect them back to back as a single 400G channel, but when you want to use breakout, you end up with 4x100G single wavelengths. And that means on the opposite side of the link, that is where you need the QSFP-100G-FR-S to detect the signal properly coming from the 400G DR4 and thus allow interoperability between your node that has the 100G interface and your 400G optics module in, for example, the VIG or line card. Last but not least, I want to talk a little bit about the 10G ZRI. When you look at the compatibility matrix, you will notice that some products, they do not support the classical SFP 10G-ZR or ZR-S. And the reason being, these classical 10G modules that offer up to 80 kilometer reach are so-called linear modules. They do require in the host line card a so-called EDC chip, electronic dispersion compensation, to compensate for the fiber effects that add unwanted signals into the transmitted signal. And as such, if you want to go up to 80 kilometers, you need to compensate for these fiber nonlinearities, and this is done via the EDC chip. The fact is that not all hardware does support these modules. Depending on the PHY chip that is used inside the hardware, they may support ZR optics or not. And as I mentioned in the beginning, when you look at the compatibility matrix, you will see that there are some products that simply do not support ZR, and at the same time, they do not support as well the classical 10G DWDM modules, the DWDM-SFP 10G and then X for the wavelengths. Now with the 10G ZR-I, we are bringing a limiting module to the market that does not require an EDC chip in the host module. With these modules, we can then bring 10G ZR reach to the hardware that so far has not been able to support the classical 10G ZR. There's only one small caveat to the story. The guaranteed reach for these 10G ZR-I is not 80 kilometers, it is 70 kilometers. That is then linked to the maximum dispersion that these units can compensate, while for this calculation we are using the maximum dispersion that a fiber can have. Under typical applications, you can expect 80 kilometer reach easily. But when we go just by the datasheet of the optical fiber and the datasheet of the optical module itself, that is when we can only guarantee 70 kilometers. That is it. Please take a look at the compatibility matrix and then see you next time for the upcoming 741 release. Thank you very much.